Bismillahirrahmanirrahim. Assalamu alaikum students. Last time we were discussing applications of Newton's laws of motion. Today my topic is coordinate systems. My topic is coordinate systems. Now you know that many aspects of physics involve a description of a location in space. For example, the mathematical description of an object's motion requires a method for describing the object's position at various times. Now, in two dimensions, this description is accomplished with the use of Cartesian coordinate system. Cartesian coordinate system. In this Cartesian coordinate system, what we do, we have two perpendicular axes like this. Let me clear it. We have two perpendicular axes like this, which intersect at a point. This point is defined as origin of the coordinate system. Then what we do, we make a grid. This is our x-axis, this is our y-axis. We're talking in two dimensions here. This is negative x-axis, this is negative y x-axis. So this is my positive y, negative y, positive x and negative x. Then every point P is assigned coordinates x and y. You know these things. Now what is x coordinate? If I draw perpendicular from P on x-axis and perpendicular from P on y-axis, now this distance, the distance from the origin to this, let me name it, let this point is M, this is N, the distance OM is the x coordinate of point P, and distance ON is the y coordinate of point P. We see how much this point is away from origin along x-axis, that is its x coordinate, and how much this point is along y-axis from origin, that's its y coordinate. Now it is understandable if in three dimensions we have another axis that is z direction, then it will have another coordinate z. Now these xy coordinates are called Cartesian coordinates. Call them Cartesian coordinates, or we also call them rectangular coordinates. They are also called rectangular coordinates, right? Sometimes it is more convenient to represent a point in a plane by its plane polar coordinates. Plane polar coordinates. It depends on the problem. Sometimes it is more convenient to use polar coordinates. Here we call them plane polar coordinates because we are talking in two dimensions. Plane polar coordinates are represented by r and theta. What's r and theta? Let me show it in the diagram. Different diagram. This was my y direction. Y dash x prime. Here, this point is my origin. Now, any point P in plane polar coordinates is designated r theta. R is what? R is distance of the point from the origin. So this is r. And theta is the angle made by this line OP with a positive x-axis, and it's measured in counterclockwise direction by convention. So this is r, and this angle is theta, right? You can see from the diagram the convergent relationship between Cartesian coordinates and plane polar coordinates. So what are the relations? X is simply r cos theta, where we know this distance is x, this is x, this is simply r cos theta, and this distance is y. What is y? Y is r sine theta. So from these two relations, if we know the polar coordinates of a point or plane polar coordinates of a point r and theta, we can find its rectangular coordinates or Cartesian coordinates, right? Similarly, you can see from the figure, I can write this is y, this is also y. So I can write, if I use Pythagoras theorem, I can write r equal to under root x square plus y square. And I can also write tan theta is yx. Now these two relations can be used to find the plane polar coordinates of a point, that is r and theta, knowing its rectangular coordinates x and y. So r square is x square plus y square by Pythagoras theorem. So r can be written as under root x square plus y square. Tan theta is y by x. So these two relations can be used to find polar coordinates of a point, knowing its rectangular coordinates or Cartesian coordinates. You must remember these relations. Next, we talk of three dimensions. We have other coordinate systems. Now in three dimensions, we talk of spherical coordinates. We also call them spherical polar coordinates. Let me draw the figure. This is my x direction, this is my y direction, and this is my z direction. Now I select some point. This is my origin. Let me use another color. And this is my origin. And there is some point P. One coordinate is we see distance of the point from the origin r. And what we do, there's another thing called theta. I will complete the figure first. You can complete also. Make notes. This is my phi, and r theta phi, right? So point P is designated with three coordinates. We said in Cartesian coordinates it will be designated by x, y, and z. So those are Cartesian, because we are talking of now three dimensions. There are three coordinates. These are Cartesian coordinates. Now in spherical polar coordinates, it is designated by r, theta, and phi. What is r? Distance from the origin. Let me write it. R is distance of the point from the origin. Distance of point P from the origin, right? As indicated in the figure, that is simply the magnitude of the position vector. It is the magnitude of the position vector. Then there is another thing, theta. What is theta? This color is dim. Theta is the angle down from the z-axis. Down from the z-axis, this angle has a name. It's called polar angle. So it's called polar angle. Then we have phi. What is phi? C. This r has projection in xy plane. Because the x-axis here is coming out of the board. So this xy plane. Now this r has OP line as projection in the xy plane. That's its projection. Then we see angle made by this projection, right? With the positive x-axis measured in this sense, right? So phi is the angle around from the x-axis. The angle around from the x-axis. It has also name. It is called azimuthal angle, right? Now here also we have the relation between r theta phi and xy z. What are the relations? Z is r cos theta, x is r sin theta, cos phi, and y is r sin theta, sin phi. I repeat, z is r cos theta, x is r sin theta, cos phi, y is r sin theta, sin phi. You can easily see that from the figure. You know the resolution of vectors. It is simple. See, this r has projection on z. That will be r cos theta. That's why z is r cos theta. This projection here is actually what? R sin theta. Because this xy plane is perpendicular to z. So R has projection, OP has projection on xy plane. That is R sin theta. So this dotted line is R sin theta. Then its projection on x-axis is x coordinate. That will be R sin theta cos phi. And its projection on y will be R sin theta sin phi. Right? Now we also define three unit vectors. R cap, phi cap, and theta cap. These three unit vectors are defined. R cap is the unit vector in the direction of increasing R. Theta cap is the unit vector in the direction of increasing theta. And phi cap is the unit vector in the direction of increasing phi. So in diagram, I can show them. R cap will be this way. Theta cap will be like this. And phi cap will be like this. These three unit vectors, r cap, theta cap, and phi cap, they form an orthogonally basis set. That means they are mutually perpendicular to each other, like the unit vectors we use in Cartesian coordinate system, I cap, G cap, and K cap. You can write any vector in terms of them. Like you write a vector in terms of these three unit vectors in Cartesian coordinates, we can write them in terms of these three unit vectors also. So if you have a vector A, is my vector, it can be written this way: AR r cap plus A theta theta cap plus A phi cap, right? ER is called radial component of A. Radial component of vector A. A theta is called polar component of A. Polar component of A, and E phi is called azimuthal component. Azimuthal component of A. We have radial component of A, polar component of A, and azimuthal component of A. There is also a relationship between, let me first remind you how we write vector in Cartesian coordinates. X I cap plus AY j cap plus AZ k cap, right? I am saying that there is a relationship between unit vectors I cap, j cap, k cap, and these three unit vectors, that is r cap, theta cap, and phi cap. I will give you those relations directly without any proof. You can write r cap as sine theta cos phi I cap plus sine theta sine phi j cap plus cos theta k cap. Theta cap as cos theta cos phi I cap plus cos theta sine phi j cap minus sine theta k cap. Then phi cap is written as minus sine phi I cap plus cos phi j cap. These are my relations. How we express these three unit vectors in terms of I, j, k. I repeat, r cap is sine theta cos phi I cap plus sine theta sine phi j cap plus cos theta k cap. Theta cap is cos theta cos phi I cap plus cos theta sine phi j cap minus sine theta k cap. Phi cap is minus sine phi I cap plus cos phi j cap. You check it at home. This is your homework assignment. You have to check it. Next, we have another coordinate system. Let me move to next page. Cylindrical coordinates. Cylindrical coordinates. We're talking in 3 dimensions again. So in cylindrical coordinates, point P is labeled by 3 coordinates S, phi, and Z. Now what are S, phi, and Z? I will draw a figure first. Alhamdulillah, sorry. So my figure goes like this. This is my x, this is my y, this is my z. Then I have some point P, which is labeled by the coordinates S, phi, and z. Use another color here. Selection. My phi. Understand this diagram. This point P. Now what are S, phi, and z? Phi, as you can see from the diagram, has same meaning as in spherical coordinates, as you can check in previous diagram. Phi is same, so it is the angle around the x-axis. Phi is same, right? Z is same as in Cartesian coordinates. Z is same as in Cartesian coordinates, that is, it is distance of the point from the origin along z-axis. Only one thing which is different is S. S is what? Distance to point P. S is distance to point P from the z-axis. From the z-axis. S is distance to point P from the z-axis. In spherical polar coordinates, R is what? The distance from the origin to the point. You can see from the diagram the relation between cylindrical coordinates and the Cartesian coordinates. So relation x is s cos phi, y is s sin phi, z is z, there is no difference. X is s cos phi, y is s sin phi, z is z. Let us say, since this is also s, its projection on x-axis is s cos phi, its projection on y is s sin phi. So relations are obvious. Here also we define three unit vectors. We define s cap, phi cap, and z cap in the direction of increasing the corresponding coordinate. So s cap will be somewhat like this. in the direction of increase of S, Z cap is in the direction of unit vector in the direction of increase of Z, and phi cap is somewhat like this, the unit vector in the direction of increase of phi. So again, these three unit vectors form an orthogonal set, like I cap, J cap, and K cap. They are mutually orthogonal. We can express these unit vectors in terms of Ij. Convergent relationships are S cap is cos phi I cap plus sin phi J cap. Phi cap is minus sin phi I cap cos phi J cap, and Z cap is same as A cap. This is how we express these three unit vectors in terms of Cartesian unit vectors. I repeat, S cap is cos phi I cap plus sin phi J cap. Phi cap is minus sin phi I cap plus cos phi J cap. Z cap is same as K cap. This is your another homework. Check it at home. Homework assignment. Right? I will give you now some homework. In addition to these two homeworks, one thing you have to check this. Another thing, you have to check these relationships. No additional homework. Let me use this color. Question first. The Cartesian coordinates of a point in the x1 plane are xy equal to minus 3.5 comma minus 2.5 meter, minus 3.5 minus 2.5 meter. Find the polar coordinates of this point. Cartesian coordinates of point are given. You have to find the polar coordinates of this point. Then I have second question for you. Question 2. This question goes like this. It says, which of the following statements is correct? First, it is possible for an object possible for an object to have motion, to have motion in the absence of forces on the object. There are second statement. It is possible to have forces, to have forces on an object in the absence of motion of the object. Motion of the object. Then I have C, third statement. Says neither A nor B is correct. And the last statement, D, it says both A and B are correct. I repeat the question. Which of the following statements is correct? Statement first, A is, it is possible for an object to have motion in the absence of forces on the object. Statement second, B is, it is possible to have forces on an object in the absence of motion of the object. C is neither A nor B is correct. D is both A and B are correct. If you find some other homework for you, question 3. It says an object experiences no acceleration. An object experiences no acceleration. Which of the following, which of the following cannot be true for the object? For the object First thing, a single force acts on the object. A single force acts on the object. Second, statement B, no forces act on the object. And the statement C, forces act on the object but the forces cancel. I repeat the question. An object experiences no acceleration. Which of the following statements, which of the following cannot be true for the object? A, single force acts on the object. B, no forces act on the object. C, forces act on the object, but the forces cancel. This is all for today. Do your homework. Don't waste your time. And don't forget to subscribe my channel. Thank you. God bless you. Assalamu alaikum.